Hello students, today we are to do the analysis of machine component using 3D element. So we have the machine component, that is knuckle pin. So its dimension is given. We are going to make this CAD model in any, you can make in any software. We are going to make in Onshape software, and after that CAD model we are going to transfer that, export that model into the step file format. So you can see the dimension of this. You can see the lower diameter of this pin is 40 and upper diameter is 60, and here there is a 7 mm extrude is there, and this bottom pin is 115, and the pinhole of diameter 5 is at 10 mm apart from this. So let's make this CAD model in Onshape software. Let's create first here document. So we have opened the Onshape software. So I will say knuckle joint, knuckle pin, say create. So now the graphical user interface is open. Now here I will say sketch. So here on the top plane, view normal to sketch plane. So here circle of diameter 40. So lower diameter was 40 and it's extruded up up to 115. So sketch extrude 115 mm. Okay, again sketch, again on this plane, view normal to sketch plane. Circle and its diameter is 60 mm. Now let's extrude this also. Extrude and its 7 mm. Length is this. Now we have completed this pin. Now next is sketch. So here we are going to select the front plane. So here we are going to make one pin hole. So here its diameter of its is 5 mm diameter, and from the bottom the distance is say 10 mm. Done. So here extrude, select the sketch. So this is the sketch and we want the through hole. So I will just select through hole and say remove. And say symmetric. So okay, symmetric and through hole. So now this diagram is completed. Now we are going to export this part into another file, step file format or IGS file format. So I will export it. So knuckle pin step, say export. Now this format is exported, you can check it. So now it is downloaded. Okay, so now we open that file in the download, you can check it. Sorry. Okay, we can open that file in the Lisa. Okay, now in Lisa, let's start in the Lisa software. So here statics, edit. So we have to select the 3D static 3D. Okay, now next is we have to select the geometry. So import. So I am going to import this from the download. So we have just downloaded it, knuckle pin dot step. Now here first meshing parameter. So we have to apply the meshing parameter. Maximum elements I'll say 1000. Okay, you want the fewer element, volume mesh, say okay. Next is, now it is not seen, so generate mesh. So it will be generate the mesh. Now you can see the mesh is get generated. You want to see the faces. Okay, now next is, you can see show the element on faces. Now what is next? Next is, we have to select it, we have to rotate. So we have to make it vertical, so we have to rotate it. So I will say rotate about x, that is minus 90. Say apply. Okay, say apply, close it. Now you can see this is rotated. Now what is next? Now we have to apply the material. So click on this, assign new material. Okay, we have to click on the mesh geometry. Say isotropic. So Young's modulus is 200 kilo Newton per mm square, and say Poisson's ratio is 0.3. Say close it. Now material is get applied. Now what is next is loading condition. So I will select the element. I will make this XY view. I will select these elements. Here load and constraint. Say apply fixed support. So here you have to select it. Load and constraint, none selected. Faces, load and constraint, new fixed support. So here we have applied the fixed support. Say okay. Now next is, again we have to select the elements. So I will select these elements. Faces, load and new force. Okay, so we have to apply the new force in x direction, minus 25,000 Newton. Say okay. Similarly, we have to apply the force here also. So select the nodes. We are going to apply the force in this section. So I will say apply force here. So this is load and constraint. So here we are going to apply the new force, and the magnitude of force is minus 25,000 Newton in my x direction. Say okay. Now let's solve this. Solve. The solution is get generated. Now let's see what is the y displacement. So you can see the y displacement here is maximum at this portion. Okay, here is also little bit. Okay, here is it no displacement because we applied the fixed support. So what are the stresses in x? So these are the stresses developed. Here the stresses are more. Red indicate highlighting the stresses. What is Von Mises stresses? The maximum Von Mises stresses is 537.1. These are the stresses that are developed, okay, at this portion. So now we have completed this simulation. I think don't we, if you want to say animation, let's say you can see. So this is the displacement in x, and y displacement is, you can see. x and y displacement. We'll stop here, close it. Okay, so if you see the tables here, the node number will be very large. Say update, you can see these are the nodes that are generated and their displacement. Okay, so we'll stop here. Let's make it isometric. Okay, so we'll stop here. Thank you.